Okay, now we learn about new type of shock, oblique shock. What is oblique shock? So most case we will have oblique shock instead of normal shock, because we have a complex shape. For example, like this rocket, the shape of this rocket will cause shock. And if you look at this line around the rocket, that is the shock. Not all of them is shock. Some of them is expansion wave. Some of them is shock wave, and some of them is expansion wave. I will tell you what is expansion wave afterward. So what is oblique shock? This complicated shock pattern which are inclined to the flow of to the flow direction. So yes, oblique shock is it will be influenced by the direction of the flow. Some portion of an oblique shock are curved, while other portion are straight. So if you look at this, the front of the rocket, the oblique shock is curve, but afterward it will go at a straight line. Okay. Now, take a look at this picture. For example, we have this flow of air at Mach number 1, and we have this object that against the flow, and what happened is shock wave can happen right here at this red line. And because this shape is sharp shape, we can straight away get the straight oblique shock, straight line. But what is the difference with the normal shock is, normal shock, the line will be perpendicular to the direction of flow. So but for oblique shock, the line is with an angle which is, in this case, is beta. Alright. So we also have this angle, delta. What is delta? Delta is the wedge half angle. The wedge half angle. So this is the wedge, we call it wedge, and the half angle is delta. And what is theta? Theta is turning angle, where when the flow when it's face the shock, it will have angle afterward, and that angle is the turning angle, theta. So as you can see, the Mach number is changing after the oblique shock as usual. Okay. So for normal shock, Mach number decrease after the shock, and only possible if the upstream flow is supersonic. So the upstream flow should be supersonic. But for oblique shock, there's some different, where Mach number 2, which is after the shock, it can be subsonic, sonic, or supersonic, depending on the upstream, MA1, and also theta. So now we also need to consider the angle. Okay. Now, how to calculate, how to measure the Mach number, how to measure the velocity. So we need to consider the angle, just like I said before. So for example, V1, that's the velocity before the shock, and V2 is the velocity after the shock. So we can have the components of the velocity, which is V1t and also V1N. What is T? T is tangential to the shock, and N is normal to the shock. Same goes to the velocity after the shock. You can also have the components, but with different angle. So what affected with the shock is only the velocity acting normal to the shock, which is V1. So V1 will be decreased, and V2 normal will be lower compared to V1 normal. But for tangential components, V1 tangential and V2 tangential, these two are the same. V1 tangential is equal to V2 tangential, because they are acting tangential to the shock wave, so it will not affect them. So this is the formula that we can get to find the theta. So according to the angle, beta, and Mach number, the initial Mach number. So we can get this formula. And for this is formula for speed of sound to convert velocity to Mach number. Okay, now this is an important diagram. So this is the relation between the theta, the angle of turning angle, and beta, the shock angle. So this diagram is produced from this equation. Okay, now there are many things that we can learn from this diagram. If you look at here, the turning angle will only appear when the shock angle, which is this angle, is bigger than 0 and also lower than 90 degrees. Okay, and if you look at here, if the Mach number, if you look at here, this value 1.2, 1.5, 2, 3, 5, 10 and infinity, if the Mach number is low, for example